The screw gauge. A screw gauge has a U-shaped frame with a flat end called stud at one end and a nut end with a cylindrical sleeve at the other end. The reference line is graduated in millimeters drawn on the cylindrical sleeve parallel to the axis of the screw. This is the main scale. The hollow cylinder or thimble is also graduated and it is divided into 100 equal parts. This is called circular scale. The thimble is attached with a ratchet by a spring. The screw is always rotated by turning the ratchet. Now let us learn about the pitch and least count. The pitch of a screw is the linear distance moved by its screw on the main scale when the circular scale is given one complete rotation. Let's see how it works. When the circular scale rotates, it slowly moves linear through the main scale. When the circular scale gives one complete rotation like this, it moves a certain distance in the main scale. Now let us see what is the least count. Least count is the pitch of the screw divided by total number of divisions on circular scale. That is, when the circular scale completes one full rotation, as we seen before, it moves one division in the main scale. The main scale has 1 millimeter in each division. Here you can see that in the main scale, each division is 1 millimeter and the circular scale is divided into 100 equal divisions. Therefore, least count is equal to 1 millimeter, that is the pitch of the screw, divided by total number of divisions in the circular scale, that is 100, is equal to 0.001 centimeter. Now let us learn about the zero error. On bringing the flat end B of the screw in contact with the stud A, as shown here, the zero mark of the circular scale must coincide with the zero mark on the baseline of the main scale. Then the instrument is said to be free from zero error. But if it is not so, with the instrument have a zero error. If on bringing the flat end B of the screw in contact with the stud, the zero mark on the circular scale is below the baseline of the main scale, the zero error is said to be positive. Let us look at this demonstration. Here we can see that when we bring that circular scale to the zero of the main scale, then the zero of the circular scale is below the zero of the main scale. You can see that demonstration again. So here it's the circular scale is rotating through the main scale, and when it touches the zero of the main scale, the zero of the circular scale is below the zero of the main scale. So in this case, this screw gauge has a positive zero error. Here the zero of the circular scale is coincide with the two divisions above the zero of the main scale. Therefore, the error is positive. This number is then multiplied with the least count of the screw gauge. So the positive zero error is equal to plus 2 into least count, that is 0.001 centimeter is equal to positive 0.002 centimeter is the positive zero error in this case. The next is the negative zero error. Let us see how do we get this negative zero error. If the flat end B of the screw is in contact with the stud A, the zero mark of the circular scale is above the zero of the main scale, then the error is negative. Here it shows that the zero of the circular scale is 2 divisions above the zero of the main scale. In order to correct this error, we subtract 2 divisions and then multiply with the least count in order to get the correct negative zero error. Here the least count is 0.001 centimeter and the zero of the circular scale is 2 divisions above zero of the main scale. So the negative zero error is equal to minus 2 into the least count, that is 0.001 centimeter is equal to 0.002 centimeter. Therefore, the correct reading is equal to observed reading minus zero error with the sign. That's important. If the observed reading is suppose some 95 and it has a positive zero error of positive 0.002, then the correct reading is 95 minus 0.002. But if it is the negative zero error, we add that. That is observed zero error minus zero error. That is the negative zero error. That becomes positive. Now let us see how can we measure the diameter of a lead shot using a screw gauge. Place the lead shot in between the stud A and the flat end B of the screw as shown here. The ratchet is then turned clockwise so that it holds the shot gently between A and B. Note the main scale reading and note down the circular scale reading as well. The circular scale reading is that which coincides with the baseline of the main scale. This circular scale division, when multiplied by the least count, gives the circular scale reading. Add the circular scale reading with the main scale reading to obtain the total reading. In this case, we can see that 2 divisions of the main scale coincide with the 96th division in the circular scale. So how can we find out the accurate reading of this lead shot? This can be again demonstrated like this. Slowly rotate the circular scale like this. When it gently touches the lead shot, see where does that scale readings. The main scale shows it is 2 divisions. It is 2 millimeter. Here you can see that when it rotates, when the stud A touches gently in that lead shot, observe the main scale reading and the circular scale reading. The main scale reading shows 2 divisions and that main scale reading is coincide with the 96th division of the circular scale. So how can we calculate the accurate reading of this lead shot? The correct diameter of the lead shot is equal to main scale reading plus circular scale reading into least count. We found that the main scale reading is 2 millimeter and it is equal to 0.2 centimeter plus the circular scale reading was 96 into the least count, that is 0.001 centimeter is equal to 0.096 plus 0.2 is equal to 0.296 centimeter. From this, we can understand that we calculated the correct diameter of the lead shot accurate to 1 by 100th of a millimeter. So a screw gauge can be used to measure the diameter of an object accurate to 1 by 100th of a millimeter.